Get started. Okay. Hello, everyone. Hello. I'm Jeffrey Kim from Markr AI, and I want to talk about what is the best component for RAG. It is quite. It is name of this session, and I want to talk about RAG, and maybe you guys listening this session, maybe you guys RAG developers or interested in RAG system, right? So every RAG developer wants to find what is the best component for RAG because you might see these. Oh, wait a minute. Okay. This is the OpenAI Dev Day slide that explains about RAG success story. They started with naive RAG with just 45% accuracy, and they add some RAG components and RAG techniques like chunking, re-ranking, or tool use query expansions. They ended up to getting 98% accuracy on their RAG system. It is quite dramatical, right? So you may think as RAG developers, you really want to implement it and test it on your RAG system on your own and hope it will be great. You will be get 98% accuracy on your own RAG system and you hope it works. But in many times, it don't work or you can't get 98% like OpenAI. So why? Because the best component for RAG depends on your documents, on your own documents and on your data. This is the conclusion, actually the most important thing in my session. So here is the evidence. Actually, I did experiment done by me. I experiment some RAG evaluation on the two different domain documents. The first one is Korean financial documents, and second one is Korean college rulebook. In Korean financial documents, the BM25 search, which is lexical search, is 5 times better than cosine similarity search, which using vector database. On the other hand, in Korean college rulebook, the vector database search, which is cosine similarity search, is 4.5 times better than BM25 search. This is really different. So the best component for RAG depends on your documents. In Korean finance documents, BM25 is great, but BM25 in Korean college rulebook, its performance was awful. And the more hard part for as RAG developers, there are so many RAG techniques and so many RAG components. I just experiment just 2 components in this experiment, but there are so many RAG techniques and so many RAG components that you almost can't find what is the best RAG component for your documents. In just LangChain or Llama Index, many people use it, and just LangChain and Llama Index, there are so many RAG components like multi-query retriever or auto retriever, auto merging, blah, blah, blah. But there was just a few components of the all RAG components. There are so many RAG components like Raptor, UPR, Visconde, blah, blah, blah. And this is so many. So you can't implement all and do experiment all one by one. It is almost impossible. So being RAG developers is like becoming medieval alchemist because there are so many RAG components and you don't know what technique is just right for your domain and right for your documents. So you may just pick one, like you like Contriver. Oh, that name is great. And you implement it and experiment. And the most terrible part that the most mistake that many RAG developers do is they don't use the quantized metric. Their evaluation just like this. They made Korean financial documents of RAG system and they think, oh, what is the great questions for my RAG system? Oh, then I will ask, what is the stock price today of Tesla? Or I will make money if I buy Tesla, like something like that. They ask the 3 or 5 questions, and if the answer is great, they think their RAG system is great. And this is the real problem. In this is the way the medieval alchemists do the experiment. So to resolve this problem, here comes AutoRAG. AutoRAG is open source AutoML tool for RAG and designed to resolve that kind of problem. So I want to introduce myself. I'm Jeffrey Kim, and I'm the lead developer of AutoRAG. I'm the leader of AutoRAG, and I am learning and studying and researching about AI since 2020. And I love open source, so I like making open source, using open source. So AutoRAG is open source. You use it right now. And as digital nomad, I want to travel around the world. So let's get started. Here is my index today's session. So I want to talk about concept of AutoRAG first and how to make RAG evaluation data using AutoRAG and the most important tips to making RAG evaluation data. And next, I will talk about how AutoRAG works. And the next part is optimize RAG with AutoRAG. I will show you some code of AutoRAG. And finally, this is an important part, and I will introduce you about how to get insight from AutoRAG results. So here is the brief concept of AutoRAG. AutoRAG is the AutoML tool which finds the best RAG components for your documents automatically. So you don't need to implement it on all RAG components one by one. So for using AutoRAG, you have to prepare your raw documents, right? And AutoRAG generates RAG evaluation dataset from your raw documents. And there are so many RAG component combinations, right? AutoRAG auto-optimize the RAG pipeline and get the optimized RAG pipeline to the dataset. So it using the quantized metrics for finding the best RAG component and best RAG combinations for your own documents. And it uses simple config YAML file for configuring each benchmark, and you don't need to use any Python code for benchmarking whole AutoRAG pipeline. And last thing, you can deploy to Streamlit Web or Fast API server, and you can test it on your own. So here is the brief concept of AutoRAG. And I want to introduce how can evaluate RAG in AutoRAG or other system. You may know the brief concept of RAG, right? There are one question, and you retrieve some passages from retrieval system, and LLM can generate it with using question and passages. And for evaluating passages, you can evaluate retrieval system. Retrieval system, like when retrieval system retrieve like A, B, C passages, and the target passage, which means retrieval ground truth passages, that contains the information to the question, to the answer question. The retrieval ground truth passage A contains the information for answering question, and you can evaluate retrieval system using retrieve passages matches to the retrieval ground truth. And next, you can evaluate generated answer. LLM will be generate answer in RAG system, and you can prepare the generation ground truth answer. And the metric system can evaluate the generated answer will be similar with generation ground truth answer. So here is the template or complete set of RAG evaluation data. You must prepare for evaluation of your RAG system. And also, this kind of RAG evaluation data set is really essential for running AutoRAG. AutoRAG using this kind of data and find the best components for your own documents. So the first part is retrieve background truth. It can be, there are many passages in your own documents. And for example, there are two passages to your query. Like passage 1 is Sam Altman said that GPT-5 will be smarter than the GPT-4. And passage 2 is Sam Altman is OpenAI CEO. Then you can make a question, or there already a question, and you can find the retrieve background truth on your corpus data set. So in this retrieve background truth, one of the question will be how OpenAI CEO think about the next GPT. And the answer, ground truth answer, will be OpenAI CEO, which is Sam Altman, think the next GPT will be smarter than the GPT-4. It makes sense, right? So this retrieval ground truth and query and answer ground truth will be the basic set for the RAG evaluation data. So for evaluating our RAG, you have to make these three kinds of things. And how can you make it? So there are several methods, but the most and the best method is getting from the real user, getting from the real user's questions and real users answer and their passages. This is the best method. But in many real-world scenario, it is like almost impossible to get great results from the real user. So the second thing is making with human expert. Like when you want to make financial documents RAG system, you may ask to the experts, which is fund manager or financial process professor. You can ask them to make great questions for your RAG system. But it is kind of expensive because human experts do a lot of things, and making questions and answer one by one is really painful, and maybe many human experts do not want to do it. So the alternative is LLM plus human strategy. LLM can generate many questions, and human can validate and adjust the LLM generation system. And the worst part, and maybe the most impossible part, is just use LLM end to end. Because as Sam Altman said, GPT-4 is quite dumb, is not smart. So when you create RAG evaluation dataset with just using LLM, the results will be quite awful. And making good evaluation dataset is like most important thing when you optimize RAG pipeline. You must contribute most of your time to make good evaluation dataset, because garbage in, garbage out. This is the essential principle to the ML, right? So I'll talk about the third option, the most realistic option. Use LLM and plus human in the loop. So first thing you need to do is parsing and chunking, right? All RAG systems need this. So there are raw documents like this PDF, and you use many parser and parsing these to unstructured text data, and use chunking method. You can get of several passages like this. So these passages will be the corpus data in AutoRAG. And next, you can select the chunk and generate the expected users questions from the target passages. So there are several passages in there, and you select one and make expected users questions. And with that question, you can generate the answer. Like for example, you select the one passage that said, if the girl do not respond your message more than 24 hours, it is sure she don't like you. This is the passage content. And when you see the content, you can generate questions like, my ex do not respond my message more than a day. Is she like me? It can be a question for your RAG system. And the great ground truth answer will be, she doesn't like you, right? So here is the example. You can generate these questions with human expert or for your users' questions, but it is really hard. So you can do it with LLM. So you can do this process on AutoRAG. You can parse and chunk your documents with Llama index and run our evaluation dataset generation code like this below. You can use your custom prompt with our simple generation code, or you can use Raga's generation, which is great library for evaluating and generating RAG evaluation dataset. So I want to explain more about the human in the loop. This is really important and really realistic option to making RAG evaluation dataset. So at first, you can generate question and answer using LLM. LLM is quite cheap than human, so you can make like thousands or hundreds of questions with that, but the quality will be bad. So you need to validate one by one. But validate is really easier than making your one by one. So you can validate the questions, you filtered out bad questions and you remain the good questions, and you can find what is the what is the point and what questions is good for your RAG system. Then you can rewrite prompt or readjust the uh, generation pipeline and generate question answering again. This is the core idea of the human in the loop QA generation. So this is the realistic option. Okay, with human in the loop, you can get great RAG evaluation dataset. Then now you can optimize with AutoRAG. So before I'll explain how to optimize your RAG pipeline using AutoRAG, I want to explain how AutoRAG works. So there are many supported RAG modules in AutoRAG, as you see, and there are too many combinations, like 3 times, 6 times, or 10 times. This is almost infinite combination to find the best RAG combination. So we optimized step by step, one by one. AutoRAG evaluates each component and parameter in a single step and decide the best one with quantized metric. So the next step only gets the previous best result and decide best module and parameter again, and the next step and the next step. So here's what I mean. In the query expansion step, we just evaluate 3 of them and select the best module. Select the best module is hide. And with the hide result, we do benchmark in retrieval step only. And we do benchmark on these 6 components and select the best one. And the next step, re-ranker step, we do benchmark in these re-rankers and select the best one. And the next step, next step, next step, next step. And in this way, you can get almost the best RAG combination. So what is the metrics for each step? As you see, we use quantized metrics for picking the best module in each step. So in query expansions to passage filter module, this is the retrieval evaluation step. So we use retrieval metrics like F1 or rank order metrics, NDCG, MAP, or MRR. And in passage compressor, we use retrieval token metrics. And the last two steps in prompt maker and generator, which is LLM, we use generation metrics like BLU or Rouge, or GEVAL, SAMScore, or burst score. You can check out our details about metrics. We don't have much time today, so I can't explain more details about these metrics. So you can check out our great blog post about these metrics. So maybe I think you can understand how AutoRAG works. So let's start using AutoRAG finally. So in AutoRAG, you can use single config YAML file for easily configure various RAG components and hyperparameters. In the previous slide, you could see there are so many RAG components out there, and it can be really hard to configure one by one or implement it on one by one with Python code. So we select this simple config YAML file. So you can set almost everything, just edit this single config YAML file. And setting good config YAML file for your RAG data is really important skill to get the best RAG result. So in this section, I'll explain how it works and how can you write on your own. So here is the really simple simpler AutoRAG YAML file. So as you can see, there are nodes, there are key named with nodes. These nodes is like each step of the RAG components. So in the previous slide, this is the each node. This is query expansion node. This is retrieval node, re-ranker nodes, and you can configure it on editing this config YAML file. So here is the retrieval node, and the next is prompt maker node, and the next is generator, which is LLM node. And in each node, you can set what metrics do you want to use. There are total 6 metrics in retrieval right now in AutoRAG, but in this benchmark, you may want to use just recall, NDCG, and MAP as retrieval metrics. And for deciding what is the best prompt at the prompt maker node, you can use these generation metrics. As well, you can use these 4 generation metrics. And you can edit this like you want to use just SAMScore to evaluating prompt maker node. You can just delete Meteor, Rouge, and burst score and use SAMScore only. Quite simple, right? And you can select what modules do you want to test. There are total 6 modules in retrieval, but in this benchmark, you may want to use just two of them, like vector DV and BM25. And you can select what embedding model do you want to use in vector DV cosine similarity search. As well as BM25, you can check many hyperparameters on our official docs. And in prompt maker node, you can set which prompt you want to use. In this example, there is only one prompt, but you can use the list and append to it the more prompts that you want to use. And the last is you can use OpenAI LLM and GPT 3.5 turbo model, and you can edit these too. You can use various models, various local models in this config YAML file, and do benchmarks automatically. So here is the example. In this generator node, you can config like you want to experiment, you want to do experiment on 2 different model and 6 different temperatures and 2 different max token level. And this will be evaluated using these 4 metrics. So this will be the combination 2 times 6 times 2 total 24 combination. This config YAM file will do benchmarks on 24 different combination of these hyperparameters and get the best result. Like use GPT-4 Turbo in temperature 0.6 with max tokens 512, like this. Okay. So when you write your config YAM file, you can use AutoRAG now. So you just use single command like this. You need config YAM file and question and answering dataset, as I mentioned before, and corpus dataset. And the last thing is project directory, which is optional, and you can get all AutoRAG benchmark results and optimization results in this project directory. So this is the brief concept of writing config YAM file in AutoRAG, and you can check all modules in our official docs. There are many components and many hyperparameters, and you can make almost infinite combination of config YAM file. So maybe if you're interested in making it in your own, please check these docs. So the last section is how to get insight from AutoRAG results. So at first, I want to show you how AutoRAG results looks like. When you complete your benchmark, you can see these kind of files. And this result project is project directory, as I mentioned. This is the project directory, and in this project directory, you can see the number folder like this 0, 1, 2. This is the trial folder, and once you start your benchmark, the new trial folder created, and you can see each node line folder and the trial summary files. Okay, the first is trial summary file. So when you open your trial summary file, you can see this, and they're the best module name from each node. Each step, you can see what is the best module and what is the best module parameters of the module. And you can find the file name for easily find what is the best module and parameters, and you can, with this file name, you can check whole results at this file. And you can, when you go inside this node line folder and node folder, you can find the node summary file. And it looks like this. The different part is you can see all combinations of modules and each module parameters. So here is the 3 combinations of module and module parameters, and you can see each metric values. We use just 3 values in this example, three metrics in this example, and the execution time of each query. So you can check out metrics values, and you can explain the result, why this module and why these module parameters is great. You can explain the result logically with these metrics. So I want to talk about the tips to read retrieval metrics and generation metrics, because there are many metrics in our AutoRAG. So I think you may get hard if you don't know about these metrics. So I want to explain about it. So the first is retrieval precision. Retrieval precision is important if the LLM have short context length, like 4K context length or 8K context length. It can be useful and it can be important. But when you use long context length LLM like Mistral or GPT-4 Turbo, I do not recommend to use it. And retrieval precision is useful when you want to reduce RAG system hallucination dramatically. And the next is retrieval recall. Retrieval recall is useful in the most case, and it is really easy to understand. When you have just only one retrieval ground truth per query, if recall is 0.5, the retriever couldn't retrieve ground truth like 50% of questions. This is really straightforward to understand. And there is retriever F1. F1 is harmonic mean of precision and recall, right? So when you don't want to use precision, when you have long context length, please don't use this metric when you don't use retrieval precision. But if you want to get a mean of precision and recall, F1 will be great choice. And the next is NDCG. NDCG is rank aware metric. These three metrics is rank aware metric, which means their weight of the retrieval system. If a retrieval system gets the answer first, it will get a higher score. But when retrieval system gets the lower rank but get the result, it will get a lower score. So NDCG is quite hard to understand and can't explain straightforward, but really effective to classify retrieval module performance. But on the other hand, MAP is really easy to understand. If MAP is 0.2, the retrieval system gets the result in top 5 retrieve passages. So it is really easy to understand. And MRR is quite similar with MAP, but different. And when you have just one retrieval ground truth per query, MAP and MRR value is exactly same. So when you have many multi-hop questions and multi-passage questions, the MRR will be useful. And it will be useful when you have multiple passages that have same meaning. And the generation metrics. There are n-gram-based metrics in AutoRAG like Meteor, Blue, or Rouge. This is the traditional NLP metrics, and this is really cheap and fast, but not accurate for long-form answer. So it needs really many ground truth for evaluating properly. So it is really cheap, but hard to use properly. Maybe if your RAG system answer can be really short, like 1 or 3 or true or false questions. It will be quite useful when the ground truth answer will be like that. Next thing is LM-based metrics. LM-based metrics is cheap and fast. They use BERT model and they compare the generated answer and ground truth answer of semantic similarity. And this can be the alternative of LLM-based metrics. And if you don't have enough resource to run local LLM or use expensive API, the LLM-based metrics can be the alternative. And LLM-based metrics is use LLM itself, so it is quite expensive, but it is accurate. It is more accurate other than metrics. So you can customize evaluation prompt by yourself if you want to use it on the domain-specific data. And this is good for multilingual data if the LLM, like GPT-4, is multilingual. And the SAM score. SAM-score have high human correlation on English data. They use embedding model to compare semantic similarity. And it is quite hard to use on domain-specific data because domain-specific data have really specific expertized words in that. So the embedding value will be bad. So it is hard to use on domain-specific data and hard to use on the multilingual data. So when you have general domain data and its language is English, the SAM score will be really good choice to using Optimize. So here is the recap. Okay, here is the basic concept of AutoRAG. Maybe you can understand about it. So at first, you can generate RAG evaluation data. The most suggestion strategy is human in the loop, and you can make your own simple config YAML file to using AutoRAG, and you can choose what is the best metrics for your own RAG system, and you can check how to deploy to Streamlit Web and API in our official docs, and it is quite simple. So this was my session, and here is my contact. Please contact me and join our Discord server and check out our GitHub page. And there's many issues out there that everybody wants to. We need help because we are open source project and we are open for any contribution to our AutoRAG project, and keep in touch to Twitter, X, or LinkedIn. So I really want to talk about RAG for many persons. So thank you. And okay, great. So I want to talk about if there is any questions. Okay, if you have any questions, please leave in the comment section. Okay, the first question is, can you okay. Okay, it is part of the YAML file, right? Okay. And the next question is, you assume that optimizing each step leads to optimizing the whole process. Doesn't it work with when each step is independent of each other, but then it may not be true? Did you happen to validate these assumptions? Yeah, that's a great point, and that's a great questions. And actually, each step is quite unindependent in RAG system, right? Because when you see the RAG pipeline, when you expand your query, the expanded query will go to the retriever, and the retrieve passage will go to the re-ranker, and this is on independent, right? But we find the most realistic because there are so many RAG components out there. So testing all combinations one by one is like you must pay like 10,000 bills to OpenAI API cost. So, and it will take a lot of time to experiment all. But in our experience and use of AutoRAG, this strategy was quite effective because this can be really the best combination of the all combination, but it will be almost best. It can be or maybe 90 or 95% best in the all combination in this strategy. And okay, do you have any more questions or? Any questions will be welcome. Okay. Okay. Maybe the time is up, right? So if you have any question and any if you have any questions or want to use or something to collaboration or want to contribute, please contact me. There are many contacts in chat. Thanks, Donggon. And okay. Okay, that's great. Okay, there are new questions. So, could you speak about the different re-ranker techniques? Okay, as you can see in this slide, there are many re-ranker strategies, and in here the Cohere and Gina AI re-ranker. These two is using the external API, the Cohere re-ranker API and Gina AI re-ranker, and RankGPT is using the LLM itself. It is like prompt engineering to the LLM and using GPT-4 Turbo. And Cohere have the multilingual re-ranker model, and Rank GPT is using GPT-4. So Cohere and Rank GPT can be a great solution if you are looking for a multilingual re-ranker or your documents will be multilingual. And there are several re-rankers out there like UPR, TART, Monty5. This is these kind of things using like BERT-based model or T5-based model, much smaller than LLM model, so it can be cheaper than RankGPT or other LLM model, except flag embedding LLM re-ranker. This flag embedding LLM re-ranker using Gemma, and the other re-rankers using small language models. So these small language model re-rankers is quite optimized to the English only. So if your documents is not English, we do not recommend to use it all on your config YAML. Great. And the other question is, if we use Gemini model, can I use AutoRAG? Of course, of course. Of course, you can use Gemini model. We have Llama Index LLM module in our generative system, and Llama Index support Gemini or other Google model, so you can use it, of course. Okay, I think the time is late, so thank you for listening our session. I'm not native speaker. I'm not English native speaker, so maybe my session was unnatural or hard to hear. But really, thank you for listening, and thank you for coming to my session and interested in AutoRAG. And lastly, please give a star and visit our GitHub repo and get a start. And thank you very much. Okay. Thank you very much. Goodbye. Thank you.